Question 3. Does the figure below have rotational symmetry? If so, describe any rotations that maps the figure onto itself. The second part of the question says, does the figure have the line symmetry? If so, describe any reflection that maps the figure onto itself. So let us discuss the first part, which is the rotational symmetry. And if I see this figure is a regular pentagon. If I am trying to draw the regular pentagon, if I connect all these vertices, and I can see it is going to be a regular pentagon. And we have learned that a regular polygon has rotational symmetry as well as it has line symmetry. So this, you can see, it is a regular pentagon, so it has to have a regular rotational symmetry. So let us work it out. So the rotational symmetry in this case is going to be (72°). Means this figure, when I rotate this, it maps onto itself at 72°, and if I continue moving this, then I can see it is again going to map onto itself when the angle is 144, but so which is a multiple of 72°. But if I go beyond that, the third time, it is going to be more than 180°, which is not considered as the angle of rotation. Angle of rotation has to be less than or equal to 180. In this case, it has to be less than 180. And if I continue moving this, you can see this figure maps onto itself again, but the angle of rotation or the rotational symmetry is given as 144, not 100, and it's not going to go beyond 180°. So this one has a rotational symmetry which is 180 72°, or the second multiple is going to be 144°. So that is the first part of this question. We can also, by calculating, we learned this, that if we have a pentagon, then we can find the angular symmetry of any regular polygon. So in this case, again we have 360°, and if we divide this by the number of sides we have, so in this case we have 5 sides, so this give me 72° is the least angular or rotational symmetry. The next one is going to be the multiple of 72°, so that is 72°, and we can multiply by the second one, and it will give me 144°. But the least is going to be the 72°, the rotational symmetry. Now let us work it out, how many of the line of symmetry we have. So because it is a pentagon, so we can have the line of symmetries. If I connect the vertex, each vertex to the midpoint of the opposite side, so that many line of symmetry we can have. And because this is a pentagon, and it is going to be 5 line of symmetries we can connect, like this one, that one, and the last one is going to be this. So this is being a pentagon, there are going to be 5 line of symmetries. So we can have this, let us draw this line of symmetries. You can see these are the 5 lines. When you have a regular polygon which has odd number of sides, then by connecting each vertex to the midpoint of the opposite side, that will be the line of symmetry, where the figure can map onto itself by reflection. So these are the 5 line of symmetries, and the angular symmetry you saw, it is going to be 72 degree. I hope you understand the question and its solution. Here is the solution. It has rotational symmetry of 72 degree or 144 degrees, which is the multiple of the least rotational symmetry, and 5 lines of symmetry being a pentagonal figure.